Hey all, this is the Algebra 2 Honors video for Friday, September 6th. You should have started with the warm-up here. Hopefully you've managed to tackle this. If not, I'll go over it right now. So we have 3x cubed minus 33x squared plus 54x. All you want to do here is take out the greatest common factor. That's the key to these problems. So what's the biggest value that goes into 3x cubed minus 33x squared plus 54x? That's going to be 3x. We're going to take out 3x, and then we'll have an x squared minus 11x plus 18 equals 0. Then you're just going to factor this again. You're going to drop down that 3x, don't get rid of the 3x, and then we're going to factor this again. So we're going to have two numbers that multiply to 18 add to get negative 11, x minus 9, and x minus 2. So our solutions are 3x equals 0, or x equals 0, x minus 9 equals 0, or x equals 9, and x minus 2 equals 0, or x equals 2. Okay? This one follows the same pattern. We can rearrange it to be negative 3x cubed plus 3x squared plus 90x equals 0. Take out the negative 3x. We're going to get x squared minus x minus 30. And we'll get x minus 6x plus 5 as our factors. And so we'll get negative 3x equals 0, x minus 6 equals 0, x plus 5 equals 0. So x equals 0, x equals 6, x equals negative 5. So for these ones, they're similar to what you've done before with factoring, but you're just taking out a greatest common factor. That's it. Okay, we're going to move on to the notes. So I'm doing the notes by hand here. This is in your toolkit. This is going to be toolkit 1.6. This is 1.6. And so we have solving by factoring. This is what I just covered in the warm-up, where we have, this is in your notes, it should be b to the fourth equals 16b squared. And so it's b to the fourth minus 16b squared equals 0. Take out the greatest common factor, that's b squared minus 16. That factors to b squared, b plus 4, b minus 4 equals 0. So b squared equals 0, b equals negative 4, and b equals 4. Okay, that's it. So just taking out the greatest common factor and then factor as normal. Okay, factor by grouping. So this was in the last delta if you didn't get to it. Factor by grouping. You want to look for this when you're given 4 terms, x to the third minus 3x squared plus 9x minus 27 equals 0. The goal here is to take out the greatest common factor of the groups. So we have a group here, we have a group here, and we will take out here an x squared x minus 3 plus 9x minus 3. And notice here that these two match, the x minus 3's match, so we can rewrite this as x squared plus 9 and x minus 3. Okay, and then you would solve this as normal. So x squared plus 9 equals 0, x minus 3 equals 0. Move this up, sorry. And we'd have x equals 3, and then we'd have x squared equals negative 9. Oops. Can we rewrite that? X squared equals negative 9, which you would square root both sides. You could get x equals plus or minus 3i. Okay. If you did imaginary solutions. If it was real only, it would be that one. Okay, that's factoring by grouping. All right, factoring fractional expressions. Okay, sorry, equations with fractional expressions. So the example is 10 over x minus 12 over x minus 3 equals -4. Okay, to solve this, you want to multiply by the lowest common denominator. Okay, which should be kind of familiar to you. Basically, it's like the number that goes into all the denominator terms. So if you multiply by x, you could cancel this, but you couldn't cancel the x minus 3. So the lowest common denominator here is actually just these two multiplied together. It's x times x minus 3. That's the lowest common denominator. So we're going to take that and we're going to multiply it here, here, and here. So I'm going to write it out so you can see what that looks like. We're going to have x minus 3 times 10 over x minus x minus 3 times 12 over x minus 3, and then we'll have equals -4x x minus 3. Okay. And then what's going to happen is this x here will cancel with this x, and this x minus 3 will cancel with this x minus 3. So after we simplify, we'll have x minus 3 times 10 minus x times 12 equals -4x x minus 3. Okay. We're not done. We still have to solve this. So you are going to distribute and simplify will be the next step. So we're going to have 10x minus 30 equals 12. 10x minus 30 minus 12x equals, here we're going to have -4x squared plus 12. We're just going to rearrange things. So we'll have 4x. This is a 12x. Minus 14x minus 30 equals 0. Take out the 2x squared minus 7x minus 15 equals 0. And you're just going to factor this as normal, like solve as normal, right? You know how to solve these. So the challenging part about these lowest common denominator problems is the simplification, right? So identifying, okay, what is lowest common denominator, multiplying every term by that LCD, canceling out whatever is going to cancel, rewriting it, distributing, simplifying, then getting it to this position. Once you're here, it's good, you're good to go, but it's actually getting to that point that is the challenging part, right? So that is equations with fractional expressions. We've got two more. Equations with radicals. Equations with radicals. Okay, so we're going to have the example given is x minus root x minus 1 equals 3. We are going to get the radical alone. So I'm going to minus 3, and I'm going to add the radical, so plus root x minus 1 plus root x minus 1. So we'll rewrite this as x minus 3 equals root x minus 1. We're going to square both sides. We're going to get x squared minus 6x plus 9 equals x minus 1. And then we'll get x squared minus 7x plus 10 equals 0. And then we'll solve this, right? So it'll be x minus 2, x minus 5 equals 0, x equals 2, x equals 5. So the gist of this one is get the radical alone by itself, and then you square it, and then you simplify it. It's kind of similar to the previous one. You're kind of given like a more complex situation. You have to square the radical to undo it, and then when it's undone, then you can combine like terms, set it equal 0, and then get a quadratic and solve. Similar to the way that with the fractional equation, you're simplifying it so that you can combine it to be a quadratic. Okay, that is equations with radicals, and then we have quadratic-ish equations. Quadratic-ish equations. Quadrat-ish. So the example given is x to the fourth minus 5x squared plus 6 equals 0. Yep, so this looks like a quadratic, right? But it's fourth into squared. What you can do is set another term, say w equal to x squared. That way, when I plug it in, it's going to become a quadratic. The 0 will stay, obviously the 6 will stay, right? But instead of an x squared there, you're going to write 5w, right? Minus 5w. And then instead of x to the fourth, you're just going to write w squared. Now we got a quadratic, right? So we can rewrite this as w minus 2, w minus 3 equals 0. And then we can solve this, right? So we're going to w equals 2, w equals 3. X squared equals 2, x squared equals 3. And so x equals plus minus root 2, and x equals plus minus root 3. Okay? That's quadratic-ish. So it looks like a quadratic, but it isn't. You substitute a term in there, and you solve. Okay? That is 1.6. So at this point, you should have your notes down for the toolkit. Now go back to the handout, and I want you to try and practice. So do this without my help to begin with would be great. I will. So right now is wherever is the Dora the Explorer style. You're gonna like pause the video, try P.6 practice A, B, C, and D. Okay, go. All right, so hopefully you've tried. At this point, I'm going to give you some hints on how to tackle these problems if you're feeling a little bit lost. So, first one is this one is probably the most challenging of the bunch. It's a fractional exponent kind of problem. And so you want to multiply with the lowest common denominator. So our LCD here, and I'm just going to write this off to the side here, is just going to be x minus 1 times x plus 2 times 4. That's the lowest common denominator here. So I'm going to take this lowest common denominator and then multiply it to each of these. Okay, and when I do that, so for the first one, the x minus 1 will cancel, so I'll just have x plus 2 times 4 plus, and then in the second one, the x plus 2's will cancel, so it'll be x plus 1 times 4. And then in the last one, the 4's will cancel, so it'll be x minus 1, x plus 2. So then from here, this is the hard part, right? Then now that you're here, you're good. You're just going to distribute, simplify, and then get on one side, set equal to 0. Okay, and then you can factor it. So try that if you haven't, but it would end up being 4x plus 8. This should be a minus 1, by the way, just to be clear on that. Plus 4x minus 4 equals x squared plus x minus 2. And so this is 8x minus 4. So I think it comes out to there is also a 5 here. My bad, there's a 5 right there. So it's going to be 5x squared, 5x, and then this will be a 10. Yeah. Where you distribute things, it should end up with 5x squared minus 3x minus 14, yeah. And then when you factor that, I believe this is 5x plus 7 and x minus 2. Yeah. So your solutions would be x equals negative 7/5 and x equals 2. Okay. B minus 1 root 2x plus 1 equals x minus 1, square both sides, 2x plus 1 equals x squared minus 2x plus 1. X squared minus 4x equals 0. 0 equals x. X minus 4. X equals 0. X equals 4 are the solutions. So get a radical alone, square it, like expand it out, get on one side, set equals 0. We had x squared minus 4x. You're just factoring out the greatest common factor x, and you get these two solutions. Okay. C, you can make your w equal to x to the third, so it's going to be w squared minus 26w minus 27 equals 0. W minus 27, w plus 1. W equals 27, w equals negative 1, x cubed equals 27, x cubed equals negative 1, cube root both sides, cube root, x equals 3, x equals negative 1. Yeah, okay. D is another factoring by grouping 1. You're just taking out the greatest common factor of these. Greatest common factor is x squared, x minus 5, and here negative 2 minus 2, x minus 5 equals 0, so it's going to be x squared minus 2, x minus 5 equals 0. And you solve, okay? So I think, yeah, and that's with x equals plus minus root 2 and x equals 5. All right, that is the practice, that is the notes. We are also doing the second round of notes. So 1.7, we're going to do 1.7. Again, I'm doing it on blank paper. So this is 1.7. So back to your notes, back to toolkit 1.7, or hang on just a second here. Yeah, this is solving inequalities. Okay, so you see we have x less than 3, x greater than or equal to negative 5, and we've got x between 9 and 3, we've got x less than or equal to 6, less than or equal to negative 2, x less than or equal to negative 5, greater than 9, negative 9, okay? So I just copied this straight from the notes. How do you write this? So in interval notation, we use two different types of brackets. So there's, I just have to come to the side here. So these, like the open parentheses is for like less than or greater than, or like infinity, negative infinity are always with open brackets. The closed brackets are for less than or equal to, greater than or equal to. Okay, that would be the closed brackets. All right, so here, the way that we are gonna write this, for x less than 3, it's like, okay, what's the highest it can be? This is your upper bound, this is your lower bound. Okay. And so the highest it could be is 3, and the lowest it could be is negative infinity. Okay, and we're using open because it's just less than, it doesn't include it. Okay, now this one on the other hand does include, so we're going to use the bracket because it does include the -5, and our lower bound is -5, our upper bound is infinity. When it comes to drawing these, if it's open, you're going to put an open hole, this would be a 3, and it would be going down, right, like that. If it was closed, oh, sorry, this one is open, because infinities are always open. That's my bad. Infinities are always open. For this one would be -5, like that. Infinities are always open. Okay. This one, I'm sure you can do this yourself. This is 3, 9. This would be -2, 6, closed. This one would be -9, -5. So this is open, closed, open, closed, half open. Okay. And then similar thing here. So from 3 to 9, be open, -2 to 6, right? Be closed, and -9 be open, but -5 be closed. Okay, that's just basic notation. Okay, so solving them, we're going to do 2 types, linear and quadratic. Okay, so the linear ones are pretty similar, pretty straightforward. So they are the same as equations, right? You solve them the same way, except whenever you multiply or divide by a negative number, flip the inequality. Okay, flip the inequality. Same as equalities, except whenever you multiply or divide by a negative number, flip the inequality. Now I'll just show you an example. This is in your notes. We have x plus 4 greater than 2x minus 1. If we solve this, by doing minus 2x here, we'd end up with negative x plus 4 is greater than -1. And we do minus 4, we're going to have negative x greater than -5. So if you were to solve this and you divided by -1 on both sides right now, you would have to flip the sign. So the sign would change to that. Okay? Because we divided by a negative number. Okay? Let's do quadratic inequalities. So, quadratic inequalities. Example is x squared plus 6x is less than or equal to -8. So the first step is to turn this into equations. We're going to write x squared plus 6x is equal to -8. So x squared plus 6x plus 8 equals 0. We're going to have x plus 2, x plus 4 equals 0. And so our solutions are going to be x equals -2, x equals -4. So solve. So like first step is like solve. Okay. Then once we have our 2 points, you're going to put them on that number line. We're going to have -4, and we're going to have -2. That's step 2. Step 3 is to test a point between or above each of these into our inequality. So we have, let's go back to this, x plus 2, x plus 4. What we're really saying here is that we want this to be less than or equal to 0, but we're going to put 0 right now. We're actually not going to even put equal 0, we're just going to leave it like that. And we're going to test a point. So let's start with a point above. So it's 10 would be fine, right? So test 10. 10 is above -2. So we'll do, you have 10 plus 2 and 10 plus 4. It's a positive, so it must be a positive number. So you put a plus here. If you tested like a -3, because that's between -4 and -2, you're going to get -3 plus 2 and -3 plus 4. So negative times a positive is a negative, so this would be negative. And then last one is just like do -10, right? So -10 plus 2 and -10 plus 4. You can see where this is going. It's negative, it's going to be positive. So take a plus here. So where is this less than or equal to -8? It would be from -4 to -2. That would be your answer. Like a graphical example of what's going on here is you kind of have like this. This is kind of a sketch of our graph, right? And like we're setting it equal to 0. And so what we're seeing is that between -4 and -2, it's less than, and above -2 and below -4, it's above. So that's when it is when we think of the original equation, that's when it's less than or equal to -8. Because we set it equal to 0, we solved for the points, we got these 2 points, right? We basically found where it equaled -8, if that makes sense. And then we tested these points in the intervals to figure out whether it was positive or negative. And that's it, okay? So when you're done with that, don't worry about this practice, that's okay. Yeah, don't worry about this, just go straight to the delta. So at this point, you're on delta 1.6, 1.7, okay? All right, guys, see you next week.